Let us discuss stationary waves and closed organ pipe in detail. Say we are given with a closed organ pipe which is open at one end and closed at other end. We bring a tuning fork of a specific frequency close to the open end of this organ pipe. We will propagate, reflect it and come back. We have discussed that a stationary wave will establish only when the open end will act as an antinode and closed end will act as a node. So in this situation, the maximum wavelength at which it can happen is the situation when the displacement curve will take this situation when the length of this organ pipe is equals to lambda by 4, because the closest antinode and node are separated at a separation lambda by 4. So in this situation, the wavelength must be 4 times the length of organ pipe. So if we find out the oscillation frequency, more precisely if the wavelength is maximum, this is the minimum oscillation frequency at which the stationary wave can be established is V by lambda, and lambda can be written as 4L. This we can also term as fundamental frequency of oscillation for stationary waves in a closed organ pipe. If we increase the frequency, wavelength will slightly decrease, then corresponding antinode node will not be made, so energy will damp out. So let's consider next higher frequency at which again node and antinode can be obtained at open end and closed end, at open end antinode and closed end node. So again, if a tuning fork is brought which is of some different frequency, such that the wavelength is reduced in such a way that one extra loop is introduced. This is the displacement curve I am drawing. Some students get confused that this is corresponding to transverse wave. Practically in air or any gas in the organ pipe, only longitudinal waves can exist. So I am just drawing the displacement curve. In this situation, there will be two nodes and two antinodes obtained. And here if we just have a look on the wavelength, it is such that this lambda by 2, this lambda by 4. So the length should be equals to 3 lambda by 4, or in this situation wavelength of the wave will be equals to 4L by 3. So we find out the oscillation frequency at which this stationary wave can be established is V upon lambda, which is 4L by 3. You can see it is 3 times N naught, or it can be written as third harmonic frequency, which is our first overtone, at which again a stationary wave can be established after the minimum frequency, and there exists no frequency in between first and third harmonic at which a stationary wave can be established. Similarly, we talk about the next possible frequency when a stationary wave can be established, which we can term as second overtone, is the one when one more loop is introduced. So displacement curve will take such a shape in which again open end will be antinode and closed end will be node. And here we can say the length of organ pipe should be equals to 5 lambda by 4, or lambda will be 4L by 5. Correspondingly, the oscillation frequency can be given as N as V upon lambda is 4L by 5, which is 5 times the fundamental frequency. We can term it N5. It is the fifth harmonic, or we can also call it second overtone. So in this situation, you can see in case of closed organ pipe, stationary waves can be obtained only at odd harmonic frequencies of the fundamental. This we can also write down and note this quite an important relation, which says in closed organ pipe, stationary waves are established only at odd harmonics or odd harmonic frequencies, or we can say when an external tuning fork is brought close to a closed organ pipe, then resonance will occur. That means when frequency of tuning fork is able to establish stationary waves, which we can again term as resonance. Resonance will establish only when the frequency of tuning fork matches with any of the odd harmonic frequencies of the organ pipe.